Hello and welcome to this first video that I'm recording on this topic of probability. My name is Timoteo and I'm doing a series of videos on how to prepare for the mathematics A levels. So if you're interested in this and you find the content useful, keep over here looking at the channel. I'm trying to upload videos as soon as possible. And I also have my website with the link in the description where you can find more explanations and more exercises as well for you to practice. So I'm going to begin this first topic by mentioning some key concepts that I believe that we should understand, concepts that I will be using when talking about this topic. First of all, what is that we call in mathematics something to be random? Essentially, we say that something is random in mathematics when we have an experience that, if performed in equal conditions, can produce different outcomes. Clear difference, for example, if I start heating water, then at a given temperature, it's always going to boil. There's no way around that. If we keep all the other conditions as well, atmosphere pressure and everything, room temperature, whatever you want to change, if you keep it the same, it's always going to happen the same. Now, if you're rolling a die, or if you go to a casino, or if you are just looking at a football game, nothing guarantees a result. I can have same weather, I can have same people around me, I can have same time of the day, and the result of rolling a die could be different. So that is what we call something to be random. When we have a random experiment, each of the possible outcomes, like the sole possible outcomes, is called an elementary event. For example, if we are rolling a die, the elementary events are you get a 1, you get a 2, you get a 3, you get a 4, a 5, or a 6. These are the actual outcomes, the actual results that the experiment can get. But then an event itself can have various interpretations. For example, continuing why we were using the one on the dice because I believe that is the most simple to understand to us. If you are going to roll a die, you can say, well, I want to think of the chances of me getting a 5. And that studies the probability of an elementary event. However, I can also think about what are the probabilities of getting an even number, or the probability of getting a prime number, or the probabilities of getting a multiple of 3, for example, or a factor of 3. So in that case, we can think of events that actually combine elementary events. For example, if I'm talking about the probability of getting an even number, I will be using the elementary events getting a 2, getting a 4, and getting a 6. So from there, you can spot okay, we can talk about the original events, the elementary ones, or we can mix them up in different ways. And then this complete set of all the possible combinations that we can get is what we call the possibility space. In mathematics, there's a whole branch that studies this that's called the sigma algebra that is not required for mathematics A levels. If you go to my webpage, you will see that I included the formal definition for a probability because a probability can be many things, and that's how you can find the probability of getting rain on a certain day or the probability that a football team wins a match. But we're not going to focus on that for the A levels. That's not going to be it's not part of the syllabus. You're not going to be asked on that. So I will keep my focus on these videos on things that will be present in the A levels exams. So then talking about probability, as we're not going to be giving the formal definition of a probability, we can give this sort of intuitive definition that works for us. That is, a probability is a way that we can measure our degree of uncertainty. And we are going to assign it a number. It's going to go from 0, that means this is impossible. For example, when I roll a die, I will get a dinosaur. That is impossible. An ordinary fair dice, okay? No, nothing strange. The ordinary fair die, I roll it and I get a dinosaur. That's impossible. I'm completely certain that that's not going to happen. On to 1. 1 is, I'm absolutely certain that that will happen. For example, me rolling a die and getting a number. I know that when I roll a die, I'm going to get a number. So from there, I am certain about that. In the middle, well, we're going to be assigning different numbers that measure this degree. How is it that we do it? Well, we do it on what we call the classic interpretation, or also known as Laplace interpretation, that has to do with an event that is studied in a random experiment where we're going to label as n to be all of the possible outcomes that are mutually exclusive. We're going to talk about that later, but essentially all of the possible outcomes that we have. And we're going to call n sub a to which of these outcomes result in the occurrence of this event that we're talking about. And then we're going to divide this n sub a over n. This is quite straightforward once you think of it. And for example, let's say that a is getting a 6 when I roll a die. Well, I have 6 total outcomes, no? So my probability is going to be probability of A is going to be something out of 6. Now the question is, in how many of these 6 events I actually do get a 6? Well, only one, because I have 1, 2, 3, 4, 5, and 6. The only one of those events where I get a 1 as a 6 is the last one. So I have a 1 out of 6 probability of getting a 6 when I roll the die. This is like the first example. We're going to see a lot of this throughout the topic. So this is usually what you know, and is the general way that we start working with probability. There are other ways. I want to mention them briefly, although we're going to be sticking to this one for mostly all of the A levels. You can also talk about frequentism, that has to do with the occurrence of a process of a certain event in a large amount of times, doing always in the similar conditions. This has something to do with what we call the law of the big numbers. That is not going to be present in the A levels, but is a very interesting result in mathematics. And if you ever get to study probability in depth, you will find this. It's very interesting. So this essentially does happen. And then finally, we have subjectivism. That I want to mention it because I want for you to know that if we are thinking about probability, we can think of it as measurement that people generally give to events. It's like we can talk about, okay, probability like in a more, let's say, classical or formal way. But I can also talk about probability, for example, when I'm thinking the clear scenario here is thinking about sporting bets. When you're thinking about sporting bets, you're actually giving value to people's perception of probability. Essentially, is that what we're doing? So that's another way that we can understand probability that has its own mathematics involved. It's not going to be parts for the A levels, but it's something that is interesting for you to think about. So having considered this, let's move on to some ideas on how we can talk about random selection, and what we talk about, we talk about the equiprobable events. And the idea is that we're going to call something to be fair or to be biased. These are two keywords that you need to know, both to be fair and to be biased, because these are words that will then uh, link you to what we understand in the task. Okay, when something in a task is presented as fair or as unbiased, we are talking about equiprobable events, while if is unfair or is biased, then there's some event that can have more probability than others. So watch out for that. So, for example, let's see this chart that I have in here for you to have as a reference. Imagine that we have a group of 19 people, 19 students. We have 11 boys and 8 girls. So, if your event were the selecting any particular boy, this means that we are setting one boy that we're looking for. The probability of selecting that student is 1 out of 19 because we're setting that particularity. However, if we're talking about selecting a boy, then our 11 boys are favorable to our event. Any of the 11 boys are going to make this event to be true because we're selecting a boy. So it will be 11 out of 19 our probability. Same thing happens here with the girls. With the girls, we have 1 out of 19 and 8 out of 19. So from there, you can get like the idea on how these things work. I hope so. If not, please do leave a comment in the section below. So with that in mind, we can move on to the first particular kind of events that I wanted to mention that are the exhaustive events. We talk about exhaustive events when we say that they include both all possible outcomes in scenario. In particular, we're going to be talking about the complement of an event that we're going to write like this. There are other notations for this that people use for the complement. They use I with a bar on top, or some other people you use A with a C on top. Those are other accepted notations for the complement. As usual, you know that for the A levels, you can use whatever notation you like as long as you are consistent with it. The idea is that when we talk about exhaustive, we talk about two key words. These are that they cannot occur at the same time. They are what we call non-compatible or incompatible. And the other very important thing is that they complement each other, meaning that one of them has to happen. One of them has to happen. For example, if we are in the experiment of rolling a die, the events obtain less than 3 or obtain 3 or more are exhaustive. It's either you obtain less than 3 or you obtain 3 or more. There's no other option. One of these events must happen, and these events cannot happen at the same time. Is that you cannot get less than 3 and 3 or more at the same time. It's either one or the other. And if you look at it, here you can see that the probability of the first event, it will be 2 out of 6 because we have two events that will uh, be favorable to obtaining less than 3. This will be 1 and 2. And then 3 or more could be 3, 4, 5, or 6. So we have 4 events out of 6. If we add these two fractions together, we are getting a 1. So from there, you can see that these events are mathematically exhaustive. Finally, the last thing I want to mention in this particular topic is what we call trials and expectation. Each repetition of an experiment is what we call a trial. And the proportion of trials can be understood as a measurement of frequency. And we can make what we call an expectation by considering the frequency as the probability of the event. For example, let's take a look at this so that we can see what we talk about in a minute. We know that in a particular day in a mountain village, the probability of rain is 0.2. And here, important thing for us to notice, you can express your probability as 0.2. You can write it as 1 out of 5, or you can turn this into a 20%. Remember that percent means multiplying per 100. So you take 0.2, you multiply times 100, and there you get the percentage. You can use whatever it is that you like. It's not going to be a problem as long as you can keep, in the case of the probability statistics, if you have a fraction and you want to turn it to a decimal, keep three significant figures. That's like the safest way for you to not lose any mark because of rounding. Never round intermediate process, right? Always use fractions in the intermediate process or the ans button in your calculator. Now, going to the question on trials and expectation. On how many days is it not expected for rain in the year that has 365 days? Well, this can be thought of in two very similar process, because the idea is, okay, we know that rain, the probability that it rains is 0.2. So I can find the expected days that it will rain if I take 365 and I multiply it times 0.2. I go to my calculator and I go 365 times 0.2, and I'm getting 73 days of rain. Now, the question here is this the answer that I'm looking for? No, it's not, because actually these are the days that is expected to rain. So I need to take 365 and subtract 73, and then I would be getting the final answer of 292 days of rain. This is one option to go around it. It's a very straightforward option, but you need to consider that the question talks about not raining. So then the other way around this is thinking about, well, a day has two options. It either rains or it doesn't rain. So if we know that the probability of rain is 0.2, then the probability of not raining, that I'm going to write in like this with an R and a approximate that is not raining, is going to be the complement of that. Remember, that is, these two probabilities need to sum up to 1. So then I just take 1 minus 0.2 and I'm getting 0.8. So then I go and say, well, I get 365 days. I multiply it times 0.8, and then, oh, that's magic. I'm getting again 292 days. A bit more straightforward. It's essentially the same thing that I did earlier. The only difference is that I changed at the beginning instead of at the end. But this is an interesting way, and keep this in mind, because the idea of taking probability like by the contrary is sometimes very helpful. We're going to be using that in other videos as well. So keep this in your toolbox. It may be interesting. Well, for the next video, I'm going to be going over some more concepts on probability statistics. So please try to watch it, and remember to uh, comment in the if you have any questions or if you want to add anything about this. Thank you very much for watching.